Hello, welcome to geometry number 3, where we're going to learn about translations. In this video, you'll learn how to translate an object. So today, you will be able to explain what it means to translate a shape. You're going to be able to read the math language to translate a shape, and you'll reinforce your understanding of what we say is a rigid motion. So we're going to start with some examples. So if we look at this particular triangle, we know that Lola translates triangle ABC to make a pattern. She draws the triangle, and then she translates it 7 units to the right to form A primed, B primed, C primed. So I want to review some vocabulary. The first is our image and our pre-image. So we learned in our last video that our pre-image is what we start with. That's our original triangle. So that's our A, B, and C. And then our image is our A primed, B primed, C primed. It's after we move it 7 units to the right. Remember that little primed, so if an A is just A, then A primed is the A with the apostrophe. So it's important when we know that we go right and left that is the x-axis. So if we go to the right, we move from C 7 units over, so 1, 2, 3, 4, 5, 6, 7 to get to C primed. A also moves 7, 1, 2, 3, 4, 5, 6, 7 for A primed, and B does the same. So each point moves. One way to draw that would be, we could say that we start with the coordinates x comma y, and then our math language would be x plus 7, and our y stays the same. So we've shown that down here is A started as 1 comma 4, and then we moved it to the right 7. That's a plus. B started as 6 comma 1. We moved it to the right 7. And B primed became 13 comma 1. And then C, we moved it to the right 7. Notice that the y stayed the same. If we moved it to the left, instead of an addition sign, we would have a subtraction sign. And if we moved it on the y-axis, we would have an addition if we went up and a subtraction if we went down. Now, a lot of times people like to draw pictures that involve shapes and patterns, and sometimes we look at patterns and we'll see that there is a transformed shape. So look at this first figure, and you'll see that the figure right beneath it is just a translation. It's slid down. You might say it slid down 2 units, 5 units, etc. Your second one is the same thing, where the one below it is a slide. It went down. In our last lesson, we introduced reflections. That would be where there's a fold or a reflection line. And you can see this next pattern is not a slide, but in fact, it would be a reflection over this line. We could say that that's the x-axis. It could be any line, but you can imagine that that top figure, I'll call it A, folded down on A primed. I'll just name the whole figure something. And then we'll say the top figure is B, and it folded down on B primed, and so on. We'll do more with reflections in another video. So now we'll look at triangle A, B, and C, and we will see that he is translating 5 units to the left. So they're asking us a question. What are the coordinates of the A primed, B primed, C primed? So what are the coordinates of the image? So remember, the starting is the pre-image. I'm going to write this in math language, and I'm going to say that every x, y went left. So it went to the left, which means it slid on the x-axis. And when it goes left, we know that that means we subtract on the x. So every coordinate will be x minus 5. Notice the y did not move, so y stays the same. So I could slide it in space, and I could say that my C primed is going to go 1, 2, 3, 4, 5, and that will be C primed. And my A primed will be 1, 2, 3, 4, 5. And my B primed will be 1, 2, 3, 4, 5. I hope you're noticing that this starts to look a little messy when I show the little bounces, but it's possible to do. The other thing I can do is use what I've learned recently, which is how to work with integers. And I'm just going to erase everything I drew for the little bounces so I can still see those coordinates. And now I will say, let's start with C. So let's say we take our C and it's 1, 5. With my math language, my C primed is going to be 1 minus 5, 5. We learned in math that a minus is the same as adding the opposite, so that's really 1 plus negative 5. And we learned that when you are working with signs that are different, you subtract and you keep the sign of the larger of the two numbers. So I'll show it off to the side. 5 minus 1 would give me 4, but my 5 has the larger absolute value, so it's a negative 4, and then my second coordinate does not change. Just look on my picture and see, is that correct? Negative 4, 5 for C primed. I think you'll see that it is. We could do the same thing with B and A. And this is very helpful when you don't have graph paper, because then you're just being given the coordinates and the language and you do the mathematics instead of having to grab your graph paper. So now we're being given just the points, but they're telling us in regular language. So it says, what is the image point? Remember, this is our pre-image or our starting value of -2, -7. Well, the first thing I'll do is graph this, x, y. Remember, -2, x always goes first, and then -7, 1, 2, 3, 4, 5, 6, 7. So here's my point. And it says it's going to go right 4 units and down 2 units. So if I count 1, 2, 3, 4, and 1, 2, this would be my new point. It wants the coordinates, so I would say my coordinates are 2, -9. As a math person, I like to write this as the math language. So x, y. It says 4 units to the right, so that means I'm going right on the x-axis, so this would be x plus 4, and down 2, so that's my y-axis. Down would be a minus, so it would be y minus 2. So if we didn't have the graph paper, what we would have is -2 plus 4 for our rule, and -7 minus 2 for our rule. -2 plus 4, we know we're doing 4 minus 2 and getting 2. And this second one really says -7 plus -2. Subtracting is the same as adding the opposite. -7 plus -2 is -9. That's exactly what we got with our drawing. Now I ask you what the image point is after a translation right 2 and up 1. Sometimes the 0 messes people up, so I wanted to include one like this. So 7, 0, first I'll graph it. Remember, it's always x first and then y. 1, 2, 3, 4, 5, 6, 7, so it stays on the x-axis. And then we're going to go right 2 and up 1. So there is my new point. So my new point looks to be 9, 1. So I'll put that there. And remember, if I wanted to write this rule in math, I would say x, y. Right 2 would be x plus 2. And up 1 would be y plus 1 because I'm going up. I'm dealing with all positives here, so 7 plus 2 and 0 plus 1. So 9, 1. They're the same. Now I have a shape and I have another shape. So the first thing you want to do is recognize that my pre-image is down here. That's the one that doesn't have the primes. My image is where it changes to, my E primed, my F primed, my D primed. So this is my image. And they want me to write the rule. they do tell me some things. They tell me it's an x minus, so that lets me know I'm moving left. I can see I'm moving left, so I'm going to take a look, and I'm going to use D just because it's the first letter as my starting point. And I'm just going to count. How far did I have to go left? So 1, 2, 3, 4, 5. It looks to me like 6. Looks like I'm going 7 to the left, so x minus 7. And then I have to get up, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I love a translation because it is a rigid motion. That means the shape stays the same, all it does is move in space. So once you find D, you know E and F follow the same rule. You just have to count. This one is another one. So you have the chance to identify your pre-image, the one without the primes, and your image, the one with the primes. And then it asks you to write the rule. So again, I'll just pick any point. This time I'll do V because it's closest to the axes. And it says X plus something. So where do I go to get all the way over to V? Be careful. Maybe identify where you're headed. And here I'll count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks to me like I'm going 13 to the right. And then I'm going down 1, 2, 3, 4, 5, 6, 7. So x plus 13, y minus 7. So in summary, a translation is a slide. If you are moving a figure, all points move according to the same rule. You can describe a translation in words or math symbols. And a translation is a rigid motion. Remember, that means the shape stays the same both in size and orientation. It does not flip, it does not turn. It just moves on the page.